Hello, welcome to our group presentation from section 5, group 3, in the subject multivariable calculus BAE 20303, which is focused in the multiple integer. Now I'm going to introduce you with our group member. First, you have me, Muhammad al-Mujtaba, my matric number AA2400, and I'm the leader. Secondly, we have Al-Fadl Al-Fatih. Thirdly, we have Al-Mughir Mutawakkil. And fourthly, we have Rayyan, Khalid, and lastly, we have Awab, Adil. About the project objective and scope. Firstly, we were asked to solve an engineering problem using manual calculation. So after we do the manual calculation, we verify our answer using MATLAB Simulink, and then we also verify our graphs. And this is what we are going to show you in the upcoming videos or slide.
Assalamualaikum, and today I'm going to demonstrate the MATLAB code of our project. So we have to calculate the volume under the plane x plus y plus z equal to 4, and then we have to plot the corresponding 3D surface. So firstly, I start by clearing the MATLAB environment by adding CLC. Then we move down and we define the volume. The volume under the plane x plus y plus z, x plus y plus z equal to 4. We rearrange it in terms of z. So we write z equal to 4 minus x minus y. So z equal to 4 minus x minus y. Then the plane equation is now z equal to 4 minus x minus y, which represent the heat of the surface. Now we have to define the symbolic variables. So let's define the symbolic variables. We write SYMS x and y, and we tell the code to define the function f equals to 4 minus x minus y. 4 minus x minus y. This function represents the heat of the plane above each point x and y. Also, this allows the MATLAB to perform symbolic, mathematical, and exact integration. So now we move to the part of double integral. To calculate the volume, we have to use a double integral. So we write define double integral v equals to integral, we open a bracket because it's double, we type integral f, the function y 0 and 4 minus x, we close the bracket, and we have x 0 and 4. Now we can close the bracket, Um, we move down, so the integration limit comes from the boundary where the plane intersect the xy plane. So we give action to display the result later. Display result is now we give an action to display the volume. So now we're done from the double integral part, and we move to the plotting part to create a triangular region bounded by 0, 0, 4, 0, and 0, 4. So first we have to define, and we tell MATLAB to plot the surface x, y equals to image grid 0, 0, 1, 4. 0, 0, 1, 4. We close the bracket. We move down. So now we write the main function, which is z equal to 4 minus x minus y, or first function z equals to 4 minus x minus y. And we tell the MATLAB to hide the negative values, so it doesn't appear in our result. Hide the negative values, which is any negative that less than 0. Z, we open a bracket, Z less than 0. Oh, bigger than 0. Equal to now we move now the inner integral integrate with respect to y, and the outer integral integrate with respect to x. MATLAB then compute the volume automatically. So MATLAB will compute it automatically. Next, before we display the result, we have to type the figure on the surface. The figure and we have to tell also the surf x, y, z. So now, as we see, the volume is 32 over 3, and my group mate Ryan will complete about discussing the result and the graph. Thank you so much.
Assalamu alaikum warahmatullahi wabarakatuh. I am Ryan Khalid, and today I will present my part in our project. First, let's point at Z here. As we look at our active 3D MATLAB, block desktop vertex represent the Z intercept of our bounding 004 plan at coordinate. Now let's point at X and Y. Okay. As this this plan slips down to meet floor intercept at the axis at the 400 and axis 040. Right now, let me rotate the graph. The plots to look directly from the top-down view to demonstrate our XY projection. This triangle is based as our exact region on the XY plan. This bounding diagonal edge is the line y equal 4 minus x from this exact projection. For our independent x coordinates, strictly span from the origin 0 to our dependent y coordinate. Track back vertically from the floor y equals 0 up until they hit the y equal 4x projection boundary, the line. Look at the command window. Output the calculated value for part A, exactly 32 above 3 cubic units. This delivers 100% verification of our manual step-by-step method using both alternative tracking order dy dx and dx dy. And thank you.
بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله. My name is الفضل الفاتح. My matic number is PE240014. Today I will show you how we write the code for our project for the question 2. So let's start. Clear. Close all. So, same. X and Y. So we define the function f equal to 4 minus x minus y. So for the double integrate, P capital equal to int and another int for the double integrate into f y. Zero, one. X and 0. So display the volume. So where the volume is, and this for the sketch, for the 3D. And line equal so 0 to 0.1 0 0.1 So what is it? Well, is it equal to 4 minus x minus y figure so x y and z x variable x y level y and z level z for the title. Let's make it Z equal to 4 minus, let's make it Z equal to 4 minus minus operating read on and shading until shading until. So let's try to run it. اسمع اقطع كهربائية. So let's try to run it. As you can see, this is the result, and I will let you with my friend and Mughira to tell you about the result. Thank you.
My name is Mughira Mutawakkil Sadiq. My matric number AE240083, and I'm going to tell you about the results. In this part, I will explain the MATLAB result. The command window shows the calculated volume in 5 cubic units. This is the final numerical result obtained from the double integration process. The graph on the right represents the surfaces z equal to 4 minus x minus y. The surface is plane that slopes downward as the value of x and y increases. From this figure, we can already see the heights of point occurred when both x and y are close to 0, where is z is equal to 4. As x and y increases, the value of z decreases, creating the inclined plane shown in the graph. In the graph result help us visualization the region used in the volume calculation and confirm the mathematical result obtained by MATLAB. Therefore, the volume of the region is 5 cubic units, and the graph verifies the correctness of the solution. And thank you for listening.